When the 2010 oil spill occurred in the Gulf of Mexico, it was only a few weeks before the storms and the tides began to deliver oil to the beaches in 5 states of Louisiana, Mississippi, Alabama, Florida, and eventually Texas. As the oil contamination spread from the beaches to the marshes, BP and Unified Command brought all of their resources to bear upon the problem. Hundreds of oil service ships were deployed, scores of local fishermen were contracted to distribute new booms and collect soiled ones, and aircraft were launched to disperse oil to keep it from reaching the marshes and the beaches. Thousands of men and women were hired at multiple ship and equipment decontamination sites established across the Gulf Coast from Florida to Texas. BP and Unified Command had also put out a call to any company or an individual who thought they had an idea that might help with the crisis. Over 35,000 ideas were submitted to Unified Command for review and consideration. 2 technologies would emerge. One was Accell Clean, made by Advanced Biocatalytics Corporation. This was a toxicologically safe and environmentally safe product that was selected for use at decon sites across the Gulf. Accell Clean was used to clean oil-coated booms, to clean out the hulls of oil service ships and barges, and to clean heavily oil-coated equipment of all kinds that was being delivered daily by the ships to the decon sites. The second technology to emerge from the Gulf was a sand cleaning machine made by Proven Technologies of Houston, Texas. This unique mobile machine could move down the beach, pick up oil-contaminated sand, process it, and re-deliver clean sand to the beach as it moved. When combined, the Proven and Accell Clean technologies could reduce oil-contaminated sand to zero detect in minutes. As BP continued to clean up the Gulf with new technologies and with the help of nature, the 2 companies focused on what the combined energies of their bio and mechanical technologies could do together. How can Accell Clean direct cellular metabolic pathways to enhance Proven Tech's mechanical pathways to make environmental cleanup faster, better, and safer? Could we launch new technologies that would first do no harm, and secondly degrade contamination to zero detect in weeks rather than years? The answer to that question is yes. We took our experience from the Gulf and directed it toward other issues facing the oil industry. Can we clean heavily contaminated soils and bring them into regulatory compliance levels in an accelerated time frame? Can we dissolve heavily compacted crude in storage tanks and clean the tanks quickly and easily? Can we separate and clean drill cuttings? Can we treat drilling muds, clean fracking pond water residue, even extract tar sands in an environmentally friendly way? By combining the extraordinary biochemical capabilities of Accell Clean with the unique mechanical capabilities of Proven Technologies equipment, we can. The 2 technologies were merged at the R&D facility in Houston, Texas. 2 low-horsepower motors drive Accell Clean treated water at ambient temperatures through a series of hydrocyclones, pipes, centrifuges, vats, and weirs. The sand is stripped of oil and sent in one direction. The separated oil moves to the surface and is weired off for collection, while the treated water is recycled for continued use. The machine is fully automated with CAD readout. We're now going to show you a video of these two technologies working together. Since this video is taken at the R&D facility, we're using a front loader to load the material, in this case tar sand, into the machine's hopper. At the actual tar sand mining site, a conveyor belt will provide a continuous feed of the tar sand to the hopper. The machine has already been preloaded with about 2,000 gallons of water treated with Accell Clean. The treated water is being continuously circulated through the system. As the tar sand or cuttings being treated move through the machine, every single particle substrate is stripped clean and separated. The critical micelle concentration and lower interfacial tension of the treated water, plus the mechanical forces of the hydrocyclones and centrifuges, strip the hydrocarbon from every single grain of sand, no matter how large or how small. The hydrocarbon, in this case bitumen, floats to the surface of the water and is moved by a series of weirs through 3 enclosed vats. Then moves across an open vat and is collected for final separation and processing. Meanwhile, on the other side of the machine, the processed sand, now clean of oil, is being sent across a series of shakers, and then it drops down into what will eventually be a conveyor belt on the site, which will take it to another area on the site for drying and eventual sale. In the process in the R&D facility here in Houston, it is being collected in bins. The bitumen produced is clean and clear with low BS&W. The sand is clean. When you pick it up with your hands, you cannot see any hydrocarbon, nor is there a smell of any hydrocarbon. And we know from testing it is in fact hydrocarbon free. This combined system has the same effect on drill cuttings. It can process thick compacted oils taken from storage tanks and easily separate drilling muds. With these combined technologies, we can take a tough oil attached to a porous surface, add some water, add a very small amount of Accell, and cause it to be stripped from its surface with no residue whatsoever. So by taking what we learned from the Gulf spill and pairing our biotechnology with our mechanical technology, we can now improve the cleanup process for oil contamination. Can we deal with environmental crisis? Yes. Can we keep our waters clean? Yes. Can we do it with environmentally sound, safe, and effective technologies? Yes. Is that better for our future? Yes. Thank you for your time.